At many organizations, you would agree with me, export compliance lives in a binder. It is documented by legal, acknowledged in onboarding training, and forgotten in daily engineering work. That approach does not survive AI for quantum systems. In this domain, export compliance is not a legal afterthought. It is a system property. If compliance is not enforced technically, it will be violated accidentally. Export regulations were written for a world of physical goods, schematics, and clearly labeled technical documents. AI for quantum systems, it breaks those assumptions. Sensitive technical capability now lives in telemetry, trained model weights, calibration outputs, configuration files, and inference pipelines. You cannot rely on humans to recognize all of this correctly. Compliance must be embedded in the system itself. I'm Nupur Mitra, a legal and governance risk translator for AI systems. On my channel, The AI Law, I unpack how AI security flaws, governance failures, and model behavior, they all turn into real legal exposure, risk issues, and the future of jurisprudence. The goal of export compliance controls is to ensure that 1. Controlled technical information is identified. 2. Access is restricted by nationality and jurisdiction. Processing occurs in approved locations. And 4. Violations are prevented by default. Compliance should fail closed, not open. Control 1. Export compliance, it starts with classification, but not at a document level. Quantum vendors must classify datasets, model artifacts, firmware, performance metrics, control techniques. Classification must be granular, reviewed periodically, and integrated into metadata systems. If an asset is not classified, it cannot be governed. Control 2. Export compliance, it depends on who can access what. So IAM systems must be able to distinguish user nationality or residency, must be able to enforce access restrictions automatically, and log and audit access decisions. So this requires coordination between HR systems, identity providers, and access control policies. Manual enforcement does not scale. Control 3. Export compliance is violated not only by people, but by infrastructure. So, controls must ensure data is stored only in approved regions. Compute jobs, they are run only where allowed. Backups and replicas, they follow the same rules. This must be enforced at the infrastructure layer. If a cloud region is not approved, the system should not deploy there. Control 4. Collaboration is inevitable in quantum development. So controls, it should require explicit approval for cross-border data sharing, review of assets involved, and time-bound access. So this turns collaboration from an ad hoc activity into a governed process. Speed comes from clarity, not from the absence of controls. Control 5. Export compliance, it requires knowing what moved, where it went, who accessed it, and when. So tracking must cover data exports, model downloads, training jobs, and derived artifacts. Without tracking, you cannot demonstrate compliance. Control 6. The most important control is this. The system should prevent violations automatically. For example, blocking access to controlled datasets for unauthorized users, preventing training jobs in unapproved regions, denying export of controlled model artifacts. So, humans should not be the last line of defense. So, why intent is irrelevant? A critical legal point here. Export violations, they do not require malicious intent. I didn't know is not a defense. This is why technical enforcement matters so much. It protects the organization from honest mistakes. Strong export controls, they enable international collaboration safely, reassure government and enterprise customers. They reduce legal uncertainty and they support due diligence for funding or acquisition. Poor compliance can halt operations, scare off investors, or trigger regulatory action. In practice, the opposite happens. Clear enforced rules, they reduce ambiguity, they speed up approvals, they prevent last-minute shutdowns. Engineers move faster when boundaries are explicit. Export compliance controls mitigate deemed export violations, accidental leakage of sensitive telemetry, model access of unauthorized nationals, and cross-border misuse of AI capabilities. They also strengthen your overall security posture. Export compliance is not separate from security. It affects system architecture, it determines access boundaries, it influences data flows. So, security teams must own this jointly with legal. So at this point, we've covered 6 major control domains: data governance, ML governance, supply chain security, hardware integrity, platform security, and now also export compliance. So the final domain, the next episode, it will focus on something often overlooked: customer assurance, auditability, and proving that all of this actually works. That's the focus of my next episode in the series. If you work on AI, security, or law and want to understand what actually gets you sued and what should change, you're in the right place. Subscribe to my channel. This channel analyzes AI security legal risk, AI liability in practice, and AI governance compliance risk. We look at how AI system design, architecture, and runtime controls, they create legal risk in AI systems, AI model vulnerabilities and compliance failures, AI runtime controls and legal exposure, and how AI tooling risk translates to law for developers, security engineers, and governance teams.